So we have a winter storm warning for tomorrow night. It is currently Friday, January 14th. It's like 7:30 p.m. And we're going to look at some models and try to figure out what this storm is going to do in central North Carolina.
We're going to take a look at some products from the National Weather Service, College of DuPage, a lot of different things out there, as well as trying to do our best to try to forecast this storm with the information we have. So again, we are not dead center North Carolina. We're more west of that dead center line. So we're a little closer to the mountains, which makes it even more complicated with topography and so on and so forth. So we're going to do our best. Like Kayla said, winter storm warning is already in place by the Greer, South Carolina National Weather Service. And let's take a look and see what we can come up with as well.
What's going on?
Okay, so first product we are looking at is from the College of DuPage. They have a great site, and right now we're looking at their satellite products that they have. And what we've done is we've overlaid some of the composite products, which is national radar. We have the this is at the surface that we're looking at is the mean sea level pressure, and then also the watches and warnings that are already posted from the National Weather Service. Okay, so what we're looking at, it looks like there's low pressure over north central Texas, and that is going to be our main player coming toward the Carolinas here in the next 36 to 48 hours. So we want to take a look at where's the clouds, where's the low pressure systems. Let's see what kind of warnings they got up. Let's see the radar at the same time to see what kind of returns we're getting. Obviously, there's not a whole lot going on with that low pressure system across the south yet. There's other dynamics and everything going on further north. But as the system continues to evolve and deepen as it moves eastward, we will expect much more radar returns to pop up across the deep south and southeast U.S. We have a strong storm off the U.S. East Coast that is spinning around and moving away. It's pulling all this cold air down. There is a strong high pressure center up here in eastern Canada. It's making its way south and east, and that's what's going to drive a lot of cold air down along the eastern side of the Appalachian chain. And that's what's going to cause what's called a cold air damming event. And what that is a lot of cold air at the surface tends to butt up against the mountains. It's got nowhere else to go. And so it'll sit there and give us really cold temperatures, kind of like the cold air is draining down from the north. So as we look at this low pressure area out over Texas, warm air is going to start to lift north out of the Gulf of Mexico. As it does, it's going to go over that dome of cold air from the cold air damming event. And that's what's going to cause a lot of our winter precipitation. It could start out as snow and then change to sleet, then to freezing rain, and it might turn over to all rain in certain locations. But again, those different winter precipitation types are highly dependent upon the lower layer of the atmosphere and the temperature profile associated with that. So as you have that warm air going over that cold dome, the depth of that dictates what kind of weather precipitation we're going to have. And we actually have a video where we talked about oh no, we didn't. Not yet. Sorry, that's in our School of Weather, which you will have to see once we get that pushed out there. But anyways, that's the setup here. So we're looking at the infrared satellite imagery. It is obviously dark out across half the United States at this point. So to see the clouds, we're using infrared satellite. Looking at the next thing that we want to see is moisture that's in the mid-levels, so about 14,000 feet to about 25,000 feet roughly. And that's going to help us identify where there's good uplift that's still occurring. And actually, we will also look at if there's any rotation at the mid-levels that will actually help to enhance some of this precipitation in the mid-levels. As you can see, the moisture here associated over Texas is associated with that low, and it is looking to push eastward here into the deep south of the U.S.
I'm seeing a lot of white moisture coming into the Carolinas, which looks pretty good for some winter precip.
That's right. And this image here, white represents a lot of moisture. Blue is a good amount of moisture. As you get into the yellows and oranges, it's kind of dry. So there's not much moisture there. So that's how we can tell where the dry area is, where the moist area is. Next, we're going to look at the infrared imagery, long wave infrared imagery, looking at something a little different in terms of the clouds and the cloud tops as well, to see how high these clouds go. And we're also looking at some of the streamlines, which is the wind flow at the upper levels. And we're seeing, again, the wind is flowing down from the north into North Texas.
Look
and
at
then
those
it turns.
arrows. They're going straight south.
And then it turns and it comes up out of the Gulf of Mexico. And the smaller these arrows are, the less the wind speed. The greater the arrows are, or the larger the arrows are, the faster the wind speed. So you got a lot of wind really screaming down here behind the system, and where you actually start seeing the arrows spinning or turning, that's where your low pressure area is. So we're just looking at that, just kind of gauging. These three products kind of shows you where it was a couple hours ago and where we are right now. Kind of see some ground truth here. Moving into the next product, this is again national radar from the Storm Prediction Center. We're kind of looking at it again. Most of the precipitation is further north, but as the low pressure system from Texas moves eastward and we start seeing it drawing more moisture up from the Gulf of Mexico, that'll all start filling in with radar returns. Here is a surface analysis of exactly what's going on here. This is from the National Weather Service. There we have that low over North Texas. We also have another low pressure further up over eastern Kansas, and then all the precipitation associated with it, as well as the fronts that are laying across the United States. And we see that warm front is extending from southeast Louisiana toward that low in North Texas, and once that low gets out a little bit further into East Texas and out into Louisiana, those winds will be able to pull more out of the Gulf of Mexico versus over land masses like Texas and Mexico.
And you can actually see here how you have the cold front coming down from the low pressure system here, and that matches the winds that were pulling all that cold air down pretty much from north to south, right behind that cold front.
Exactly. That's what they call in Texas a blue norther. So
a blue what?
A blue norther is actually what they call it. Yeah, is when a strong storm system goes through Texas and you get that strong north wind that just clears out everything. And these cold fronts go all the way down into Brownsville, Texas. It'll clear most of Texas at this point, and
cool.
The whole state will be clear. So they call it a blue norther, blue sky, and clears it all out. So
I learned something new today.
Interesting.
And now it is time for everybody's favorite part, predicting the future with the models.
Yes. And remember, we are looking at one layer at this point, and basically we are looking at Tropical Tidbits, one of our favorite websites.
A+ site.
Yes, and we are looking at the GFS model. We are looking at the surface, and so we have mean sea level pressure and lows and high pressure systems, as well as precipitation, forecast precipitation.
Yeah.
And I think it is the 6-hour accumulated precipitation rate is what it is. And so when we get into our color scale over here, we have snow in this color scale, sleet in this color scale here, freezing rain in this color scale, and then the regular liquid rain in this color scale. Okay, so this model run, the GFS model run at 18Z, which is 1 p.m. Eastern Standard Time. That is when this model initialized, and we can see that the low pressure area is back there over North Texas. And if we advance this to our current time, which is around 8 o'clock p.m., we're going to move forward. I've got to going a little
0 Z's right there.
Okay, 0 Z's right there. Perfect. Okay,
it's
so that's as close. Yes, that's as close as we are to the current time. Maybe we're off by about an hour, but there is the low pressure over north central Texas that we've seen. Here we go. So there's our low pressure over north central Texas. So the model initialized that, and looks like it is going to take a track to the east. And it's really pulling down some cold air at this point. You'll notice that the model will show low pressure at certain areas, and it's kind of bobbling around a little bit based on where it's predicting things to be, but you just kind of have to look at the general trend of where it's going.
Imagine it as like a smooth line.
Yeah, it kind of bounces around a little bit. There's reasons why it does that, but for right now, to keep things simple, we're just going to kind of look at the general trend of where it's going. So it's moving often in an easterly direction, and it might bobble a little north and south of that line. But as you can see, as we go from the current time, as the winds start coming out of the south and southwest, it's pulling moisture in from the Gulf of Mexico, and now the models are forecasting precipitation to start occurring here. Looks like it is mid-afternoon Saturday across Louisiana. And as we continue to move forward in time, again, there's cold air to the north and west of the low, so that precipitation will transition over to snow, is what they're predicting based on the color code here. And this is still mostly just all liquid precipitation at this point. So where it gets really interesting is this high pressure system over here over Ontario. A lot of the winds are coming around clockwise in the northern hemisphere and going toward this low, which is spinning counterclockwise. So winds are coming in off the Atlantic, and as it's doing so, a lot of cold air is draining down the east side of the Appalachians, setting up what we're going to experience as a cold air damming event, especially along this region here. So as this moisture is going to start moving east to the east side of the Appalachians, you're going to notice a little bit more precipitation more on the frozen side. That's what the model is trying to let us know. So here we go. We're moving forward. As we get into Sunday, you'll start seeing the low pressure is continuing to move easterly, and then we start seeing the precipitation.
Some pretty colors going on.
That's right. And what I'd like to do is actually, let's go to a southeast view so that we can kind of zoom in a little bit on what's going on here. So let's take a look here. So there we have over North Carolina a lot of different precipitation types.
Yeah.
So, and as we continue to move forward about another 6 hours at this point, it gets very messy, very complicated. Low pressure is still over here over Georgia, and depending on some models, they're trying to forecast whether this low will stay together and just continue to move along, or sometimes in these situations this low will come over and it'll get close to the mountains, and then it'll transfer a lot of its energy to a low pressure system just off the coast. When that happens, that's when it gets really tricky to forecast, because all this moisture then tends to kind of blow up right along the coastline, and your forecast becomes a bust when you're going for a lot of precipitation.
North Carolina is a very difficult state to forecast for because it's so close to the ocean and it's kind of in the middle of the East Coast, and you've got the Gulf of Mexico, and then you've got whatever's coming from the Midwest, and you have to take into account what's over Canada. Just a strange state to forecast for.
It's a challenge.
It
definitely is a challenge to forecast for these regions.
One that I am not always up to, which is why Dad is narrating most of it.
Well, I'm doing my best, right? So that's pretty much what we're looking at here. We'll go ahead and step through this. I'll bring us back. Okay, and then kind of move us forward. So this is mid-afternoon on Saturday, January 15th, and then we're going to go ahead for the next 36 to 48 hours, and you see it gets to be very complicated over the I-85 corridor of North and South Carolina, which is in this general area here.
Happens to be our general area.
It's our general area, and we are proud of it.
Oh, goodness. What an adventure. What do I see? I see sleet. I see freezing rain. I see more sleet as we step through time.
There's our snow. Here's our sleet. Snow. Here's our freezing rain, and here's our rain. And so that is 12Z Sunday. So there's 7 a.m. Eastern Time Sunday morning.
And then there's more
6 hours later.
Oh, goodness.
So let's see here. So it's going to be pretty exciting, seeing this come through and trying to predict what's going on here. So basically for our area, they are forecasting wintry mix.
Just all of it.
Everything's in the bag, except for rain.
No
We're
rain.
far enough north that we're not going to see liquid precipitation, but start off as snow, transition to sleet for a little bit, or mix with sleet for a little bit later in the morning on Sunday, and then it should turn to sleet and freezing rain in the afternoon, and that should stick around for a while. And then as the system moves out, the cold air comes back in. Looks like we're transitioning over to snow. Now, there's one more thing that gets very tricky about storm systems crawling across the south in the wintertime. And that is, do you know?
Does it have to do with the warm nose?
There's the warm nose too that we can talk about. Why don't you hit on that real quick?
So warm nose is basically, you can have your upper level is obviously going to be very cold because you're high up in the atmosphere. And you can even get below freezing temperatures on the ground. But if you have in those mid layers any kind of warm air coming through and raising it even to 33 degrees Fahrenheit or 34 degrees Fahrenheit, anything above that freezing line, your snow is going to fall from the top of the atmosphere. It's going to hit that, what we call warm nose, and it's going to melt. And then it's going to come back through another cold layer, and depending on how thick that surface cold layer is, it'll either be freezing rain or sleet.
That's a tricky thing too, and we can go there real quick. We're going to go to the thermodynamics, and we're going to go to what we usually look for that warm nose is at the 850 millibar layer, which is about 5,000 feet. And so here you can see,
there
according
it
to
is.
the temperature scale here, so 0 is our freezing. Anything in the green gets warmer, anything bluer gets cooler. And you can see at midday Sunday that warm nose, let me back it up a little bit, and you'll see the warm nose further north. So there it is. So here we go. As that low pressure comes along, it starts making its way further up into North Carolina, and then continues to move up, but gets pushed away as the low pressure center continues off to the north and east, and then the cold air comes back in. But that's the tricky part, is where is that warm nose? As you can see, the North Carolina mountains are still cold, so it'll stay snow there. But once you get out into the northwest Piedmont, it starts getting a little trickier to forecast.
But watch this. This is, look how tricky this is. As we're going through here, look at this line of where that warm air is. If that moves even, 10 miles, it's the difference between us getting snow or like sleet and freezing rain. And that is a major factor in a lot of meteorologists busting in this area, because if that line moves just a little bit, your snow totals of 8 inches of snow all of a sudden becomes 4 inches of snow with like power outages and ice and all that.
That's right.
So there's that. And then if we go back to our original thing here, and let's go to that midday Sunday and go roughly central Piedmont. Let's click that. We're going to get a sounding.
There's your warm nose.
Here's the warm nose. So here's our freezing line here. And then here's the surface, and we're going up in the atmosphere the farther up we go. As you can see, the surface is very, very cold, and the upper levels are very, very cold. But here's that freezing line. You can see as we're going up in the atmosphere, we're getting warmer and warmer. And there's that little nose right there.
Right there at that 850 millibar layer.
Yep. To kill the snow potential. So this is probably, what would you say? This is a sleet profile. So it's got plenty of time to freeze back up. So it's not going to stay rain and then super cool when it hits the ground.
So let's talk about that for a minute. So the red line is the temperature, and the green line is the dew point temperature. So where they're close together, obviously the relative humidity is very high, so you're expecting moisture.
Yep, if they're overlapping, it's raining. Or it's precipitating.
Precipitating, right. So let's say both these lines were to the left of this 0 degrees C. How would you do that?
Just click on an area that's got snow.
Perfect. Okay. So again, as you're going up in the atmosphere, everything is to the left of the 0 degree C temperature line here. So when snow starts to fall from up in this layer here, it's going to continue to stay below 0 degree C, or the freezing line, and it'll just continue to reach the surface as snow. So now let's take a look at here. You have again, if the precipitation is falling from up in this region here, and it's making its way down as snow, and then it has a brief period of time to warm up and turn into liquid.
Mm-hmm.
And then it crosses back over a little bit lower, back under freezing again, and so it has time to freeze. But at this time, it doesn't go back to a snowflake.
Correct.
It turns into a sleet pellet. And then eventually it will reach the surface as sleet. Now let's take a look in our freezing rain category, and you'll notice,
there it is.
let's say the precipitation again is falling as snow comes down and melts. And now if you notice, the nose is a little bit lower to the ground, and usually with that case it goes ahead and it melts, and now it's liquefied. And then again, now it's closer to the ground by the time it crosses over that freezing line again. Now it does not have enough time to change back to a sleet pellet by the time it reaches the surface. So it stays liquefied, but it becomes super cooled because now it's below freezing. But it doesn't freeze. So it's a super cooled water droplet. Now, when it hits the surface, if it hits something that is below freezing, like a bridge or something metal, like
top of your car,
a
grill.
Yep, absolutely, where the temperature is below freezing. So what it'll do is it'll make contact and freeze on contact. And that's where you get freezing rain. And then if we look at a profile number 4, which we are completely in the warm sector on this, you will notice that, yep, precipitation may fall as snow. Well, actually it won't fall. There's nothing here because this is kind of dry, unless this is bogus, but let's say it's liquefied here, right? Or it's precipitating here. Okay, so it'll come down and you see that there is a large amount that is above freezing, liquefies, and then stays liquid all the way to the surface because the whole thing here is above freezing. There's your 4 precipitation types and an explanation of a warm nose.
Yeah, that's a big thing for especially snow in the South. We get a lot of warm noses. So if you also live in the South, this could be the thing that, either makes you really upset that you didn't get all that snow or makes you really happy because it didn't snow.
That's right. And to what degree that warm nose makes it north is determined by a number of factors. The track of the low pressure system, the 850 millibar jet, that 5,000 feet, which way the wind is coming from, how fast is it flowing, is it going to bring up that warm air? There's a lot of different factors. Winter weather forecasting, especially here, is very complicated.
There's a lot that goes into it.
And even those that have been doing this for years will definitely tell you this is not easy. And it's always best to give a range. You can't really pinpoint. You can't pinpoint because one area could get more based on it might be a little bit warmer, might be a little bit cooler, 10 miles away, topography, a lot of things play a role.
Are you by a lake? Are you not by a lake? Right. Is it? Yeah. All this other stuff plays.
Yep, exactly. So it's always good to give ranges for temperature, precipitation, and that way there isn't a huge surprise. Instead of saying 10 inches of snow and then you get 6, it's good to say 6 to 10 inches. Yeah. But that's a good standard that the National Weather Service adheres to, and I think that's really good.
So do we want to throw in a Meteotech forecast, since we are going to be measuring the snow totals and everything during this event?
That's right.
Do we want to give a range of our own? What do we think?
I already took a look at things earlier today.
That's
I have my numbers. So
I'm going to defer to the expert here. And
Where? Where's the expert? Please, I'd like to ask them.
Kayla's guess. All freezing rain and disappointment. That's my forecast.
You've been disappointed so much a lot.
It normally is.
I know. Well, taking a look at what we've got right now, I'm looking at us having somewhere around 4 to 8 inches of snow and getting about probably half an inch to an inch of sleet and 0.1 to 0.15 inches of freezing rain. Now, when that all precipitates and compacts down, we'll probably, at the end of everything, it'll be about a 3 to 5 inch snow depth. That's my guess right now. Well, it's not really a guess. It's a forecast based on my experience and looking at the models, and it's always subject to change. That low tracks 20 miles further offshore or on inland, changes everything. And as of right now, they actually have a 1/4 inch to a 1/2 inch of ice southeast of the I-85 corridor. So if a storm, moves 20 miles inland, that whole thing shifts. So that puts a lot of people, right in the crosshairs. Or if it shifts further away, it puts it out more in the rural areas and doesn't do as much damage to the Charlotte metro area, et cetera, et cetera. So winter weather forecasting here, it's quite the challenge. Could be very rewarding when you nail it.
But it could also be, you get shredded apart on social media if you're wrong. So.
Yeah. We just do our best with the advance in technology that we've got. I think it's improved over the years, definitely.
Yeah.
But does have a ways to go.
It's what we're working with right now.
That's right. And it's really hard, I know, for a lot of folks, myself included, when you get forecasters or weather people that say it's going to be, a foot of snow and it's going to be 30 degrees, it's going to be windy, and then the event happens and you get all rain, it's 45 degrees, and it's just total opposite. And it's very disappointing because you're planning on certain things happening, or you're hoping for rain and then it winds up snowing and it totally busts your plans. So, we get that. You kind of have to go to trusted sources, people that you've seen through weather events and, get their forecasts pretty good. Not everyone's going to nail it every time. It's very hard to do, but there are those that know their stuff. They're going to be very consistent in their forecast. They're not going to be extremely specific. We're going to get 0.53 inches of ice right here.
Yeah.
Well,
if you see a forecast that is specific, it is going to be 31 degrees. You're going to get 6 inches of snow. There's going to be 0.5273 inches of freezing rain on top of that, and the wind is going to come out of the northwest for only 2.5 hours before switching. Ignore the forecast. It's way too specific. Way too specific. Unless that's happening at this moment, way too specific.
That's right. Pinpoint forecasting, great concept, but it's not really practical because there is such a range.
Yeah. So there is our Friday evening forecast and kind of walk through the models. Tomorrow we're gonna check back in again and kind of do the whole process again, see where we're at, see where things are in relation to where they're predicted to be tonight, and then the main event is Sunday morning. So keep watching.
That's right. The next 36 hours is going to be exciting.